All right, we're about to embark on a 2-day lesson on differential equations. Again, there are entire college classes on differential equations. College students often will say Diff-EQ for short. And as you can see, man, there's all kinds of uses for them. I know that we've done things with differential equations in pre-calc. You know, we did the Newton's law of cooling in a couple sections, and obviously in science you can see we've got Newton, Einstein, Schrodinger, a lot of the big names. Riemann is involved as well, Poisson. Aside from the classical uses of differential equations, one of the coolest modern uses of differential equations is in search engines. I always wondered how Google is programmed to find things when you type in, cat videos or whatever. They use Diff-EQs. So obviously that's above my pay grade. I don't know how it's done, but pretty neat. All right, let's try some differential equations. Starting with number 1. Okay, we have a mystery function, y equals f of x. I don't know its equation. I do know the second derivative, however. And I know that the slope of the function is 8, and it goes through the point 411. That's enough for me to work backwards, which is really what this is, to figure out what f of x is. So since I have the second derivative, I've got to integrate twice to work my way back. So let's integrate both sides. We're actually going to integrate with respect to x. Over here on the left, the integral of the second derivative, of course, is just simply the first derivative, dy dx. Over here on the right, we're integrating the 3/4 x. That's going to end up being 3/8 x squared plus c. Now, a fair question might be, hey, why don't you do the plus c on both sides? And that's fair, but if you have a plus c on both sides and you go to move one over, you know what c minus c is? It's not necessarily 0 because c is a mystery number. C minus c is still c. Isn't that crazy? So that's why we only need to write it once, and typically we write it on the right-hand side. All right, at this point I'd want to integrate again, but I don't know what c is, that plus c, and that is bothering me. So let's find it for sure. We know that the slope is the derivative, and the slope is 8, so I can put an 8 over here. And that happens at the point 411, so x is 4, y is 11. So we have 3/8 4 squared, which is 16. Little canceling here. Let's see, 1 and 2. We have 6 plus c is going to be 8, and so c is 2. All right, so I'm going to rewrite that red differential equation. I'll take out the plus c. In fact, I'll do it right now. Put in a plus 2 in its spot, and then I can move ahead. All right, now we're going to go ahead and take an extra integral. We're going to integrate this. Before I do, I'll move the dx to the right. Integrate that. Let's come up over here. The left-hand side, the integral of dy is simply y. And on the right-hand side, we're going to end up with 1/8 x to the third. Up by a power, divide by the new power. Plus 2x. Plus another c. I'm going to call it d. A lot of teachers will go c sub 1, c sub 2. That's fine as well. I think I'll just use a different variable. And we need to figure out what d is, but again, we can use the xy. We can use the 4, 11. Just don't get it backwards. Y is the 11. X is the 4. 4 to the third. 4 times 4 times 4 is 64. That will cancel later. That's nice. 2 times 4, that's going to be 8. Speaking of 8, this is also 8. So we have 8 plus d. 16 plus d is 11. Subtracting 16 from both sides, you can see that d is going to be negative 5. Now, that's not my answer. Some students will circle the negative 5. The final answer is this right here. Remember, it says find the function y equals. We just have to knock that d out and replace it with a negative 5 or a minus 5. And that's the answer. That's our first differential equation. We actually did a harder problem because we had to integrate twice. A lot of times it's only once. All right, that's number 1. Back in middle school, you may have been exposed to the PERT formula, which is a way to figure out your bank balance if your interest is compounded continuously. Also, you may have seen it written as KECT, C-E to the KT, or probably more likely in science class, written like this, where AO is amount original, T is time, A is the new amount, K is a growth constant. Anything that has exponential growth or decay that goes on all the time will use this formula. And I'm going to show you where it comes from, and not surprisingly, since we're in that section, it happens to be differential equations. To begin my proof, there's really only one thing that you've got to buy into, and that's this equation right here, which pretty much describes life. dy dt is a derivative, therefore it's a rate. It's the rate at which something happens, like the rate of a reaction, let's say. Y is the material that you're dealing with. And then dy dt is how fast that material breaks down. For example, when I was younger and a little more stupid, we used to, play truth or dare, and we used to, dare each other to do dumb things in lunch. Fourth grade boys are. And one of them was how many atomic warheads you could put in your mouth at once. Those were those sour candies. And, oh man, you get like 4 or 5 of them in your mouth and your eyes would start to water. But basically, the more that you ate, the stronger the reaction was. So think about Y being the number of pieces of candy that you have stuffed in your mouth, and dy dt being the rate at which your eyes water. When Y goes up, the other side, the dy dt, is going to go up. K is just a constant based on the material that you're eating. Obviously, you can have a mouthful of mashed potatoes, and that's not going to make your eyes water, where sour candy will. So the sour candy would have a higher K value. But basically, the more of something that you have, the faster it's going to react. So anyway, let's go ahead and move on with this equation. The first step to solve a differential equation is to separate the variables. I want to get all the y's and dy's on the left. So I'm going to divide both sides by y. That'll knock that out. And then I'm going to get rid of the dt. I'll multiply by t over here on the right, or dt I should say. Knock that out. So we have 1 over y dy equals k dt. All right, so all the y's and dy's are on the left. All the t's and dt's are on the right. There aren't any t's, but if there were, they'd be on the right with the dt. And the k is just hanging out there. All right, let's integrate both sides. The integral of the left will become natural log of y, technically absolute value around that y. I don't need a plus c over there. I'm going to put one on the right. Integrating the k gives me kt. Remember, k is a number. If you integrate like a 7, it'll be 7t. If you integrate a k, it'll be kt. It's not 1/2 k squared. K is not a variable here. The variable is the t. We know that because of this dt differential. All right, plus c on the end, because that's what we do. That's the constant of integration. Can't forget it. And now we're going to solve. Well, to get y by itself, we've got to get rid of that natural log. And what better way to get rid of a natural log than by using its inverse, e? So we're going to make a base of e on both sides. This process is called exponentiation. We are exponentiating both sides. As I mentioned, e and natural log are inverses. They will simply cancel each other away. Over here on the right, we're going to do a little bit of algebraic trickery. We have e to this power, and the two red items are being added together. So I'm going to say e to the kt times e to the c, which is totally allowed. Think about algebra. If you had, e to the 5th times e to the 2nd, that wouldn't be e to the 10th. It'd be e to the 7th. E to the 5 plus 2. See what I did? I just went backwards here, going from here to here. Okay. Hopefully that made sense. If not, stare at it for a little while, see what you think. Okay. Speaking of e to the c power, you know what e to the mystery number is? It's a mystery number. So instead, I don't need to write that. I can just write one big, large c in its place. In fact, that big, large c is being multiplied. I can put it wherever I want. How about out front? Let's do that instead. We don't need this guy. We'll get rid of it. And speaking of getting rid of things, let's get rid of the absolute value as well. We'll come over here. If you get rid of absolute value, you've got to put a plus minus on the other side. So I will. But since c is a mystery number, and I don't know if it's positive or negative right here, then what's the plus minus really doing for me? I don't really need it. The c could just sort of devour it and it would be gone, and that's exactly what I'm going to do. And ladies and gentlemen, I have just reinvented the Kecht formula, PERT formula, whatever you want to call it, and it comes from differential equations. All right, that's pretty nice. You can see, start to see the power behind these things. All right, let's do some more regular examples. Here's my number 2. Find the general solution of the differential equation. General solution means we're going to have a plus c in our answer, which is fine. First things first, let's separate variables. We'll kick the dx to the other side. dy can stay put. If you want to throw a little 1 there, that's fine as well. All right, integrate both sides. The integral of 1, some people might say x, but here it's y, because the derivative of y is 1 if you go backwards. This will tell you what variable to use. That's why they're important to have at the end. Those little dy's and dx's, they're called differentials. All right, over here on this side, if you go up by a power, you're going to have x squared divided by 2. That's going to be 1/4 x squared. Again, plus c. And guys, we don't have to make this difficult. That is all there is to it. That is our answer. That's the general solution. So whenever you see us say find a solution, we're looking for y equals. You can also call it f of x if you want. Something that you could type into a graphing calculator. Y equals is already on the screen. You got to find the other side. All right, let's see another one. How about number 3? Oh, that's like the exact same problem we just did, except instead of 1/2 x, it's 1/2 y. And that's going to change everything. So again, let's separate the variables. I'm going to kick the dy dx to the right. I will do that every single time. Multiply by that there. But we can't have the y over there. That's got to be on the left. So we will divide both sides by y. Can you sense an absolute value natural log coming on? I sure can. I see that 1/y dy. I know I'm going to be integrating. In fact, let's make that our next step. And the integral of 1/y dy is simply the natural log of y. Again, you can't natural log negative numbers, so to be safe, I'll put the absolute value on it. The integral of 1/2 dx will be 1/2 x plus c. Okay, so far so good. Just like in the previous problem, or in the previous proof, we've got to get rid of the natural log, so I will exponentiate both sides. And again, the absolute value of y will come down. I'm not going to write the absolute value on it. Instead, I'll just throw the plus minus on the right. And so it's going to be y equals plus or minus e to the 1/2 x, or x over 2 if you want, plus c. And that plus c is in the exponent. Okay, so that's a totally fine answer. And if you want to do some additional algebra, you can make it, e to the c, bring the c in front. Most textbooks won't do that. I just wanted to show you where that middle school formula came from. Pretty typically, we're going to leave answers like this. Now, later on, when it doesn't say general solution, when it says find the particular solution, they're going to give you, or I'm going to give you, another piece of information, and we'll be able to figure out what the plus c is. And we're also going to be able to get rid of the plus minus. It'll be one or the other. Okay, but those problems are coming later on. For now, so far so good, I hope. All right, number 4, find the general solution. Same thing, we got a diffie-q. Interestingly enough, we have y prime. And when I first taught derivatives, everybody wanted to use y prime. I'm like, eventually you'll start using dy dx. And they're like, I don't know. And now I put a y prime on and it bothers everybody. So let me change the y prime back to dy dx. First we have the regular y. And we'll get busy. Let's knock the dx off of the left. Let's multiply over here on the right. We have separation of variables. Again, College Board will freak out on you in the free response question if you do not separate variables. You're going to take a 0 out of 5 or 0 out of 6 before the problem even starts. Okay, so separating variables is so important. Now that we have that first step done, we will integrate each side. At least this time, the left is no longer a natural log. It's going to be 1/2 y squared. Again, no need for a plus c over there. We'll put one on the right. The integral of cosine is just sine. Not negative, just regular positive sine of x. Because again, if you go backwards, the derivative of sine is cosine and the 3 drops down. All right, so that's our almost answer. We have to get y equals. So let's just double everything. We'll multiply everything by 2, so we get y squared equals 6 sine of x. And this is going to seem a little weird, but you know what 2 times a mystery number is? It's a mystery number, so typically we don't put the 2 on the c. Leave it off. And then finally we want y equals, so we square root both sides. That will force a plus minus on the right. And a large square root. How large? Large enough that that plus c better be underneath it. And we've got to preserve order of operations. I realize it's a mystery number, but the mystery needs to have a lid over the top of it. It's got to be inside the overhang. Safely inside the square root. There we go. That's number 4. All right, number 5. We start out the same way with the y prime. I'm going to go ahead and switch that over again to a dy dx. In fact, you know what? Let's just kick this to the other side. So instead of equals 0, we'll have equals positive 3 e to the x. This problem's a little different. Look at the directions. It says find the particular solution of the differential equation. So instead of a general solution, we will not have a plus c any longer. Well, we will in the middle of the problem, but we're going to figure out what the c is. And our answer will not have a plus c. We also have this extra little nugget of information here. Y of 0 equals 1. I secretly hate when textbooks write it like that, even though it's correct. I prefer to write 0, 1, make it look more like an ordered pair. That way I know that x is 0, y is 1. If it bothers you, and you're afraid that you're going to write 1, 0 instead of 0, 1, I do have students that have that fear, just come up here, take some red marker or red pen and scribble out the parentheses and stare at it. I'm like, y equals 1, okay. I guess I won't get it backwards. And then remove the said parentheses, splotch, and carry on with your everyday business. All right, one more item to take care of. Let's get the dx over where it belongs on the right so that variables have been separated. And now we'll integrate. On the left side, we're going to again have 1/2 y squared. I've seen this before. On the right, the integral of 3 e to the x happens to be itself. You can check by taking the derivative, but it is. But we have a plus c. All right, I could multiply both sides by 2, do the square root and all that, but it makes me nervous to be messing around with a plus c and trying to do algebra on it. Like a couple slides ago, I was like, hey, if I double a mystery number, is it 2c? No, it's just c. That's a weird conversation to have. That's a bit too philosophical for me. I'd rather know what c is. And then when I mess around with it, at least I know what I'm messing with. So let's get that 0, 1 plugged in ASAP, as soon as humanly possible. Now remember, the x is the 0, the y is the 1. Don't put it in backwards. So on the left-hand side, we have 1/2 times 1 times 1. That's a half. On the right-hand side, we have 3e to the 0. That's 3 times 1. That's just 3. Plus c. Subtract 3 from both sides. And it looks like c is going to be negative 2.5, negative 2.5. I'll call it negative 5/2. They all mean the same thing. I think the negative 5/2 will be the easiest to deal with. And I'm going to put that back up where the plus c was in red. I'm going to change that to a minus 5/2. There we go. Nice. Now I can do the algebra without fear of saying something weird. Maybe I will anyway. Let's double everything. Let's multiply everything by 2. So the left-hand side will simply become y squared. And on the right, we're going to have 6e to the x minus 5, because everything gets doubled. Now we square root both sides. So we have y equals, again, we get the plus minus on the right, and a big square root. But unlike before, I'm not going to circle this quite yet. One of those signs, either the positive or the negative, has to go. And it's not always the positive that wins out. It's about 50-50. But one of them is right, one of them is wrong. And what you do to figure out which one to keep is you go back up to the original point, this point 0, 1, and you plug it in. Remember, y is the 1, x is the 0. So 1 is plus or minus the square root of, let's see, 6e to the 0 is going to be 1. 6 minus 5. All right, so 1 is either positive or negative, radical 1. Well, obviously, it has to be positive in this case. So the positive we're going to keep. The negative we're going to remove. So the blue answer is correct. We just need to remove the sign in front. In fact, I can remove them both since it is positive. And there we have it. The particular solution to the differential equation. That y equals graph will go through the point 0, 1. I think you can see that. And its derivative is correct. All right. I think we've done a good job. We're going to take a break. We'll come back for day number 2 out of 2 on differential equations when we meet again.